Okay, this next problem is kind of a doozy to wrap your heads around. The goal is similar to the previous one, where we want to create a box out of something flat. In this case, it's cardboard. We're told we have a 10-inch by 10-inch piece of cardboard. We want to cut some holes out of this, fold up some corners, and get a box. But this one's a little bit unique that we want to have a top on this box. All right, so a picture is drawn over on the right-hand side, and we are asked to find the dimensions of some box that has the very largest volume. So the largest volume, we need to represent volume. Well, volume can be computed as length times width times height. All right, so if you kind of visualize what's going on here, the yellow regions are going to be gone. We're going to fold this side up, so the height is going to be whatever x is. So whatever we represent as x, that's going to be our height. Now the width and the length are kind of interchangeable, which one you want to call which. Let's first try to represent this distance going across here in the middle. Okay, so what's going to happen to get there, and this is the easier of the two, that's why I'm starting with it, is it was 10 to go all the way end to end. But we're taking away from that this x and this x to get the entire front of our box as it's labeled there. All right, so that would be 10 minus 2 x's. Now the last part here is the length, going the opposite direction. So let's see if we can wrap our heads around this. Okay, going all the way across here is 10. But we have to cut out an x here and another x here. Okay, like these boxes on the ends, these are going to be the same. And then this side gets folded up. But we have to kind of compute how far is it going across here and the bottom, right? We want the top and the bottom to match up. So when we fold this up, the very front of the top wraps around to the very front here. All right, so we started with 10. We took away 2 x's, right? Those are these values right here and right here. So we have 10 minus 2 x's, and then we want to divide up whatever remains equally. So what I'm going to do is I'm going to take 10 minus 2 x's, but then I have to divide that 2 ways, right? So it's equal for kind of back to front on both the top and the bottom. All right, now we've created the function. It may take a second to wrap your heads around. That's all right. Grab some paper, cardboard, cut some corners out, make it look right. Okay, next I'm going to go ahead and start simplifying down our volume function. So the first thing I'm going to do is I'm going to take that 2 in this fraction, and I'm going to reduce this down. I'm going to put a 2 with each one of those terms in the numerator. And I'm going to simplify. All right, we can say that's 5 minus x for that first set of parentheses, 10 minus 2x over here, times an x on the outside. My end goal here is I want to find the derivative and find critical values. So to do that, what I want to do is I could pull out like the product formula, but I'm going to multiply this out. I'm going to take a little bit of time, distribute, FOIL if you will. I'm going to go 50 first, outer, inner, last. And we still have that x on the outside. Next, I can go ahead and combine some like terms. All right, we have 50 minus 20x's plus 2x squared with the x on the outside. From here, let's bring that x to the inside. That'll make it just a nice polynomial. So 50x minus 20x squared plus 4x cubed. Okay, from here, let's go ahead and I've got a couple things that I'd like to do. One, I want to find these critical numbers, so let's find the derivative. Now that it is a nice polynomial function, I can just use the power rule a few times. We'll get through this. So we can say 50 minus 40x plus 12x squared. And I care about when this derivative equals 0. So to figure out when this equals 0, let's go ahead and... Wait, did I do that right? This is wrong, all right? I brought the x to the inside here. This is supposed to be 2 out in front. I am not redoing this. All right, so this was still a 2 out in front, just coming down. So now as I take my derivative, it's going to be 6x squared at the end. Now I'm going to rearrange this and put this in descending order. So 6x squared minus 40x plus 50 equals 0. And I want to think about solving this quadratic down. I'm going to go ahead and try to factor out a common factor to begin with. Because if we can factor it, I usually tend to try to do it that way. So what I'm going to do is we have a 2 in common at least. So let's remove a 2. That'll leave us with 3x squared minus 20x plus 25. I don't think we have any more common factors, but let's go ahead and think, can we factor any further? Now we could do the AC method or a different method if you want, but this one does factor a little bit further for what's inside the set of parentheses. This will factor as 3x times x to make the 3x squared. And then the 25 can actually factor as 5 and 5, with both of these being negative. All right, see a different factoring video if factoring is where we're struggling on this. All right. To finish up and find our critical values, let's go ahead and set each factor equal to 0. Treat these like separate equations. This one's going to be pretty easy to solve, right? Just add the 5. On this one, we have 2 steps. We add the 5 and divide both sides by 3. So we have 2 different values for x. We have 5/3, and then we also have 5. Are they both good values? All right, these are both referred to as critical values. But could we use both of them? Let's think about how we represented the length, the width, and the height. Let's say, remember we had x equals 5/3 and x equals 5. First, let's think about the 5/3. Now let's think about 5. So as this was set up, if we had 5, we only had 10 going all the way across here. So if I took 5 out from this side, and I took 5 out from this side, that's going to be a little bit of a problem. All right, we've taken away all 10 inches the whole way across. So we can't actually use that. 5/3 would be okay though, right? That's a little less than 2. So if we take a little less than 2 out from this side, a little less than 2 out from this side, we can still form a box. So I'm going to say that's going to be our nice solution on this one. So let's use that. And we are asked to find the dimensions. So one dimension here, basically I'm going to use how we represented the height, was going to be 5/3. The width, we can get that by saying 10 minus 2 times 5/3. I'm going to do a little bit of algebra to simplify this down. This will be our width. 10 minus 10/3. Well, I can rewrite that with a common denominator by multiplying by 3/3 here. 30/3 minus 10/3 is 20/3. Okay, so that's going to be our width, 20/3. Exact answer here. And then the last one, let's find our length. I'm going to use this version of our length down here. The length is going to be 5 minus x. So 5 minus 5/3. Again, get a common denominator. So 15 thirds minus 5/3 is going to be 10/3. Can represent our length, an exact value there. Now, if you wanted to find your maximum volume in this box, you would multiply 10/3 times 20/3 times 5/3. We weren't asked for it, but let's go ahead and find your maximum volume. All right, we've already represented these. We said 10/3 times 20/3 times 5/3. All right, as we multiply all of our numerators together, we get 1,000. And multiply all of our denominators, we get 27. I guess our units were in inches, so this will be cubic inches, or that's right around 37.037, repeating cubic inches. All right, we're going to ask for that maximum volume, but we've already found all the information we needed. All we had to do was one last multiplication. All right, hope this helps out. I know this can be a confusing problem from the beginning. Take your time, wrap your head around it. Drawing a picture sometimes isn't enough. You actually have to get a piece of paper out or cardboard and really try to visualize it. But I hope this does help. Good luck.